Hey guys, welcome to tutorial number 6. In this tutorial I'm going to show you guys how auto-resize works. So I've got this scene of just a couple of emitters and a bound pretty much a 2D container. So whenever I play that, see what's going to happen. You've seen this too many times, of course you know what that is. Now if I turn on pay attention, okay? Nothing is happening, the boundary box is constant, it's not moving whatsoever. So if I turn on auto-resize, what I'm actually telling it is like, okay, what I'm telling it to compute differently. When auto-resize is on, auto-resize will dynamically resize 2D and 3D fluid containers whenever the voxels near the outer boundaries of the container have a positive density. For example, the 2D and 3D fluid containers will expand or contract according to the current density of the field. So now that one is on, see what's going to happen. Bang. It's resizing according to the current density of the fluid, right? Whenever the fluid is lower, it will be small. Whenever the fluid is like expanding, has a positive density around the edges, the fluid container will continue to expand. That's how auto-resize works. Now, resize closed boundaries. As this one works the same way. It's a way to resize the closed boundaries. So let me just open the properties. When resize closed boundary is on, like right now, the fluid container will resize along the axis that has have their respective boundaries set to none, both sides, minus side, or upside. So at the moment it's set to both sides. Okay, so which means the the boundaries will resize both sides. So basically that's the best way I can explain that. I hope it makes sense to you guys. Resize to emitter. When resize to emitter is on, the fluid containers use the fluid emitter's position to set its offset and resolution of the scene. So turning resize to emitters on is useful in fluid effects with animated emitters. Okay, things like let's see, a fireball or fireworks and stuff like that. It will make more sense once you start using it. For now, all you have to know is resize to emitter is useful when working with animated emitters. As easy as that. Otherwise, it's not that useful. But I still like to use it here and there. Maximum resolution. Maximum resolution specifies the average maximum resolution per side that a fluid container resizes whenever resize to emitter is on. Okay, so maximum resolution works hand in hand with resize to emitter. That makes sense, I'm sure. Resize in substeps. When resize in substeps is on, auto-resize the fluid containers will resize each substep. Alright, I hope that makes any sense. When resize in substep is on, auto-resized fluid containers will resize per substep. Okay, each substep it will resize. So when resize in substep is off, fluid will only resize one voxel per simulated step. I hope that makes sense, guys. So bear in mind that collision boundaries are evaluated per substeps only when auto-resize and resize in substeps are on. Okay, keep that in mind. So dynamic offsets. Dynamic offsets displays the local space translation of the fluid that is computed when auto-resize is on. So Maya either sets the values during fluid auto-resizing or reads them from the fluid N-catch files. Fluid N-catch files, I'm sure you don't know what they are, but I'll show you later on during the future lessons, okay? Because right now you don't really need to go that technical. Otherwise you just confuse yourselves. I'll confuse you because you blame me at the end of the day. Auto-resize threshold. I don't know where you come from, guys, but I'll say threshold. I hope you get my accent. So auto-resize threshold is set to 0.010. What auto-resize threshold is okay, when auto-resize threshold is on, auto-resize threshold will set the density threshold value that causes the fluid container to resize. Okay, when auto-resize threshold is on, it will set, because right now the density threshold value will be 0.01. So whenever the density value reaches 0.01 and above, auto-resize will activate. Otherwise, it won't activate if it's less than 0.01. Okay, that's just the density. You already know what that is. Auto-resize margin. Now, this is the last bit. Auto-resize margin. This is a way to specify the number of empty voxels added between the fluid container boundaries and region of positive density in the fluid. Okay, auto-resize margin lets fluids flow more naturally near auto-resize boundaries and is useful for fast-flowing or low density fluids like honey, something with lower viscosity, like something with a high viscosity, sorry guys, like honey, olive oil, that's another thing, or something like water, depending on what it is. Okay, depending on what it is, you can you can play around with auto-resize margin. Okay, depending on what it is, whether you're playing with water, the honey dripping out of a cup or whatever it is, or olive oil, things like that. And again, this will make more sense once we start playing with fluids. Like if it's too thick, I can just rechange the auto-resize margin to higher or lower depending on how I want the flow to be. So anyway, that's what auto-resize is on, or that's what auto-resize is all about. So again guys, I hope this makes sense, and if it doesn't, go back to the beginning of the tutorial and play it again. It has to make sense before you can proceed. Thank you very much. Make sure you subscribe, and I'll see you in the next tutorial.